Section 11.3, number 37, we want to find the area of the shaded region. So here, here, and here. Another way to think of this problem would be to find the area of the entire circle and then subtract the non-shaded regions from it. And that's what I'm going to do. So, the area of the circle minus the area of the non-shaded sectors, and there are 3 of them, so I'm going to take 3 times the area of one non-shaded sector. So the area of the circle would just be pi r squared, where our radius is right here, 2 inches, minus 3 times the area of one of the non-shaded sectors. So since my central angle is 45, the area of one of those sectors would be 45 over 360 times the area of the circle, which is pi r squared. Pi times 2 squared. From here, I can simplify this a bit. So 2 squared is 4 pi. I can also simplify here. So let's see, 3 goes into 360 120 times. And 2 squared is 4. I can continue to simplify. 4 goes into 120 30 times. And simplify this fraction, divide both numerator and denominator by 15, and we get this. So we have 4 pi minus 3 halves pi. What is 3 halves? 3 halves is the same as 1 1/2. So 4 pi minus 1 1/2 pi would give me an answer in terms of pi to be 2.5 pi, and then I can go to my calculator and just type that in. So 2.5 pi is approximately 7.9 square inches. And that would be the area of the shaded region. Number 39, the figure shown below is a sector of a circle if the perimeter of the figure is 22 millimeters. Find its area in square millimeters. So for this problem, there's multiple steps. What we're going to do is first use an equation for perimeter in order to solve for the central angle, and we'll call that x. So this angle right here. Once we know what x is, then we can use x to find the area of this sector. So my perimeter, which is 22 millimeters, is equal to this side, which is 6, plus this side, which is 6, plus this side, which we don't know. So we can call that another variable. We'll just call that y. Now we have to solve for y. So what is y equal to? Y is equal to a portion of the circumference. So it is given by the formula x over 360 times circumference, which is 2 pi r, where our radius is 6. So we can simplify that a bit and get x over 360 times 2 times 6 is 12 pi. And now we're going to substitute this in place of y into our perimeter equation, because ultimately we want to solve for x, because we're going to use x to solve for the area of this figure. So 22 is equal to 6 plus 6. Let's go ahead and simplify that. It'll be 12 plus y. So in place of y, we're going to put all of this. So that's x over 360 times 12 pi. And we're solving for x, so let's get rid of this 12 first by subtracting 12 from both sides. So 10 is equal to x over 360 times 12 pi. We can simplify here since 12 goes into 360. We go in 30 times. So now we have 10 is equal to x over 30 times pi, which we can also write as putting the pi over 1 here. So to get x by itself, I'm going to multiply both sides by 1 over pi. And 1 over pi on this side would cancel that out. And I'm just left with x over 30. I can also write that as 10 over pi is equal to x over 30. And to get x by itself, one last step, I have to multiply both sides by 30 to get this 30 to cancel out. So 30 times 10 is 300. So I have 300 over pi is equal to x. So now that we know what x is, we have an expression for x, we're going to substitute this into our formula for area of the sector. So our area of the sector is equal to x over 360 times area of the circle, pi r squared. So we're going to substitute in 300 over pi over 360, and we're going to substitute in our radius, which is 6, right like that. So we can also write this as 300 over pi times, since I'm dividing by 360, that's the same as multiplying by 1 over 360. And 6 squared is 36. So now I can write this as 300 over 360 pi times 36 pi. And I just start canceling things out here. So I have pi, which would be in the numerator if I made this into a fraction with the pi in the denominator. I can cancel out a 0 out of both of those, divide them both by 10. I can cancel out a factor of 36 here with a factor of 36 there. And that's about it. So I'm left with 30. So that's our area, 30 square millimeters. For number 41, find the area of the shaded region. So we have this shape. And how would we get that shape? Well, we can see that just this part right here is half of a circle. So we could take half of a circle, and then we're subtracting away half of a small circle out of that. But then we're adding half of a small circle back. So these two areas cancel each other out. And then I'm just left with subtracting away half of a small circle. So really the way that I like to think of this as is taking half of a big circle and then just subtracting half of a small circle away from that area. Because like I said, this area here and this area here balance each other out. So we don't need to even consider that. So area of half of a big circle minus area of half of a small circle. So, what are our radii? The diameter of the large circle is 12, so half of that would be a radius of 6. So, from here all the way across is 12. So, if we divide that by 3, each diameter of a small circle is 4 inches. 4 inches and 4 inches. So if we take half of that, the small circle will have a radius of 2 inches. And now we can just substitute in. So area of half of a big circle. So we want half the area, pi r squared, pi times our radius is 6, minus the area of half of a small circle. So half of pi r squared, where our radius is 2. So I would get 6 squared is 36, and 4 squared is 4. So half of 36 is 18, half of 4 is 2, and 18 minus 2 gives me 16 pi. Then to your calculator, 16 times pi is approximately 50.3 square inches. So that would be this area here of the shaded part. All right, that's it.